All right, in today's lesson, we're going to do the review of secants and angle measures, or segments and angle measures. So if we look at problem one, we have an inscribed angle problem. We're trying to find the inscribed angle, and we're given the intercepted arc. And we know that if we take half of the arc, we will get the angle. So the answer for number one is going to be 34 degrees. Again, half of the arc equals the angle. On number two, we had a theorem that stated if we have a quadrilateral inscribed in a circle, opposite angles in the quadrilateral are going to be supplementary. So if we take 180 minus the 101, we're going to get the value for x, which is going to be 79. And we can do the same thing here. 180 minus 93 is going to equal to 87. All right, and number three, there's two ways to do number three. The first way, they give you an inscribed angle. And if we double that, that will give us 148, which is going to be the value of the arc. And we know that the entire arc is 360 degrees. So if we take 360 minus 148, we get 212. That would be one way to do this problem. The other way, if this is 74, we know both of these have to add up to 180, making this inscribed angle 106. If we double 106, we would get the arc, which is going to be 212. So again, either way would be fine in this case. All right, down here, there's a couple ways to start this problem. Probably the most common, people would take this arc of 144 and divide it by 2, and that would give you your value for x, which is going to be 72. Now, at this point, there's two ways to go about this problem. A lot of people will say, well, all three of these angles add up to 180. So if we take 72, 51, and this would all add up to 180, which gives you 57. Once you have 57, we can double it to get the angle, the arc here, which would be 114. So those are the two answers we have. Now, an alternate way to find this is after we find 72, that takes care of this, we can double the angle to get 102, and then use the arcs to find the missing arc, which is 114, and then take half of that to find z. Either one of those strategies would be acceptable. Those are both fine. All right, on number 5, we have two chords intersecting in the circle. Now again, this is not the center of the circle, so this answer is not 66 and is not 108. So what we end up doing on this is we're going to add up these two arcs, divide by 2, and we're getting an answer of 87. And again, that formula came from the notes where it talked about that, and it had the example next to it. All right, we have two secants intersecting outside the circle, and this formula in class was described as the big arc minus the small arc divided by 2 is equal to the angle. So in this case, 134 is the big arc. Okay, x is the small arc. We're going to divide by 2, and all of that will equal to 26. So the first step in this problem is to take 2 and multiply it by 26. So we end up with 134 minus x is equal to 52. And from here, you should be able to solve that equation and get 82 as your answer. All right, the last three questions here are segment lengths of different shapes. So in number 7, we have two chords that intersect, and we want to find the segment lengths of those. So what the formula in the notes told us to do is take one part of the line and multiply it by the other. So in this case, 12 and x, we're going to multiply together. On the other line, we have 8 and 6, so we're going to multiply that together. So we're left with 12x is equal to 48. X is equal to 4. So that would be your answer for that problem. All right, number 8. The shortcut on this problem is we take the length of the whole line times the part that is outside the circle, and that's going to equal to the other line, the length of the other line, times what's outside the circle. Okay? And so if we look at this example, I'm going to call this the brown line. Okay, so we have the whole line times what's outside in brown, and then we have the whole line times what's outside in green. So the length of this entire line is 24 plus 8, which is 32. That's the length of the whole green line. 8 is outside of it, so we're going to multiply these two together. When we go to the other line, the length of the brown line is how much? It's x. We don't know. That's what we're trying to find out. How much of this is outside? Well, the entire thing. So we multiply it that way. And we know that x times x is going to be x squared. And x squared is going to equal to 256. So to get x, we actually have to square root 256, which is going to give us an answer of 16. Okay, so again, we take our whole line times outside, and that's going to equal to the whole other line times what's outside of that other line. And that's how we do that. We're going to use the same strategy for number 9. Same strategy. So here, the green line, the length of that green line is x plus 8. And how much of it is outside? There's 8 units long outside. The other line here, the other line is 16 units long, and 6 of it is outside. So we're going to leave it like so. All right, 6 times 16 is 96. And then on the left side, we have to distribute. We have to be careful because this is the type of step where many students will make mistakes. So we do 8 times x and 8 times 64. So we end up with 8x plus 64 is equal to 96. And from here, we should be able to solve this two-step equation and get 4 as an answer. These are the certain examples, very basic examples of most of the simple concepts for inscribed angles, their arcs, their intercepted arcs, and then the segments and angle measures of chords and secants.